Okay, welcome to episode 2 of EthanThatOneKid's Codecast. And in today's episode, I'm going to be writing an interpreter from scratch. As you can see, I'm using a heart-eyed cat emoji because the word scratch reminded me of Scratch, the programming block coding thing. Anyways, so today's topics for writing an interpreter, I just put some tags right here. We're going to be using Deno, and we're going to be writing a new language that I'm going to be calling Neo. I've worked on Neo before, but right now I'm completely revamping it from scratch, and I'm going to be writing the interpreter in Deno. The next keyword is interpreter because I'm going to be making an interpreter from scratch today, if I haven't told you already. And npm is also a keyword because as a side experiment sort of thing, I'm going to be, even though it's going to be a Deno project, I'm actually going to be using a package.json for because it's possible in Deno to compile all of my code into JavaScript into an ES6 module. So I figured perhaps it's possible to compile all of my Deno code into an ES6 module and then ship it as an npm package for backwards compatibility with npm. So if I want to use my interpreter in Node, I could install it through npm. So that's what I was thinking. These in the news things I will go over in a little bit. As we code, I'm going to take 30-minute. Every 30 minutes, I'm going to take a break to drink some water or look at the news. So here is our plan for today. So for today's episode, I will attempt to complete all the components of the interpreter, but if I cannot, I will continue this checklist into a later episode. And by this checklist, I mean these development steps that I have written here. These are just some notes that I'm going to do that'll help me. They're just arbitrary things, but just good notes. So what have I learned? So this is episode 2. Which implies that there was an episode 1. So what have I learned from my episode 1? Well, in my last episode, I wasn't chill enough. I was kind of uncomfortable and I felt exasperating and too exhausted and confused, not chilled out. But today I'm gonna take a chill pill so that I'll be chill. Also, I did not like the way my audio turned out. Also, I didn't like the way my what else? My image quality. I didn't like the way my image quality came out either. So I took some time to tweak the settings, so hopefully it sounds better and hopefully it looks better too. And what the heck am I doing? Well, I'm going to write my Neo interpreter in Deno, but I will be allowing for backwards compatibility by publishing my module as an npm package post bundle. So in the early stages of this, I'm not going to completely write out everything and then barely test this part. I'm actually going to try to test this part early-ish. So development steps. I think I can start now. Like the last episode, I have a split right here, but today, since it's just a chill episode, I don't have any instructions for myself, so I just have one split, so it's just one timer for today that I'm going to be pausing and stopping. So I guess I could start now. I have some notes as well up here that I'm going to be looking at sometimes, maybe, perhaps. Ideas about my interpreter. So yeah, I think I'll start now. So it should be number 7 on my keypad to start the split. Let's see. I'm using another keyboard for my splits. Let me see if it's on. I haven't even tested it. That's bad. Silly me. Oh, it's dead. I think the battery might have ran out because I haven't used it since the last Codecast for the same purpose. So I guess I'll just start the split. How will I start it? Because I guess my batteries are dead. Okay. That's okay. I can just do a timer instead. I could do a timer. No, I like the split. No. Okay, here's what I have to do. Edit this. Not edit splits. Oops. Not that. I need to just go to the options. I need to change my start one. I'm going to put it as, I'm trying to think, what can I put it as that will not be clicked as I'm coding? What will I not be clicking? I'm not gonna click. Maybe I should do that. That's like an undo button for starting and stopping on my keyboard. Starting, stopping, I could go right here for pausing. So start is going to be okay. Start is going to be, I'm just writing some notes. Start is going to be one that says undo, and my pause is going to be cut. Okay, cool. So I'm gonna start now by pressing undo, I guess. Oh, it worked. Alright, cool, we're in. So Lexer, blah blah blah. So, oh yeah, I'll just start. Not the notes. I need to go to my plan. So my plan is rename the current Neo repository to Neo Cli. So yeah, my original Neo repository is actually, it contains everything. It's a whole client and everything. Too much. Too much. I'm going to abstract the interpreter part only because this whole repository is like a mono repo and it's really unorganized. I didn't like the way I did it. So I'm actually going to readjust everything. So go to the settings. I'm going to rename it to NeoCli for now, and this repository I'm going to keep, but it's going to get a major overhaul because I'm going to, in the future, just like how I said I'm going to do this backwards. The whole reason why I want to use this npm thing is because I want backwards compatibility in order to make a CLI. CLI stands for command line interface. I wanted to make a command line interface as well as, like, yeah, that's all I'm gonna say. I'm gonna rename it to NeoCli. I pronounce CLI as Cli, so sorry if you're not used to that. It's just how I read it in my head. So now I renamed it to Neo Command Line Interface. It's been done. It's really been done. I'm sorry to say. But anyways, what's the next thing I wanted to do? Create a new Neo repository. So yeah, now that I renamed that, I should probably rename or make a new one. Add new repository. My new repository is going to be named Neo. And oh, I just had an idea for my OBS. So instead of this being in the way, maybe I should have it off screen and then make it another, like, source on here. I can add a window capture. Okay, and I'm going to make it this. Cool. Now I can put my window capture down here. Cool, okay. That's cool. So now it's like all separate. That's kind of cool. I'll keep the time right there. There we go. How does that look? That's good enough. Cool. Okay, hopefully that looks good. Okay. Now it's not even in the way for me. I can see this whole section. I can see where this is covering it. Okay, so making a new repository. I'm going to, what was the original description? Scripting language for web automation. So I'm going to say something similar to that. A scripting language. So it is going to be a scripting language for web automation, but this is the interpreter. So I'm just going to say a scripting language interpreter. A web automation scripting language interpreter. A web automation, comma, scripting language interpreter. Perfect. So I'm going to start with a README. License, I should probably do MIT. Get ignore, I should probably do a node. Get ignore, actually I want to do a custom get ignore. So I'll add the node one for now, but I will edit it. I'll probably clear it actually. So here we go, starting a new repository called Neo. Here we go. And let's open it in desktop so that I can code it on my desktop. I should probably file or repository remove. I should probably remove this one. Actually, yikes. Hopefully this doesn't break everything. It's probably taking a while just because I decided to put it in the recycle bin. Okay, I should try that again actually. Because I already had that old one that I just renamed to NeoCli. Interesting. Okay. We're good. Okay, we're good. Now I'm opening the new project. Here we go. New Neo project. Let's go back to the plan though. So after we create the Neo repository. So for people who want to follow along or whatever, I already have npm installed. I already have Deno installed, but I'm going to install Denon, which is the like NodeMon version for Deno. It's basically allows me to recompile my program over and over again. So I'm going to open a terminal and I'm going to say, I'm gonna show you npm version. I have my npm Deno version. Oh, oopsies. I meant to say like dash dash v. Oh. Oh. Is it like this? There you go. Dash dash complete version. Okay. And now I'm going to make sure that Denon is installed by going and writing this here. Here we go. Boop, bada bop boom, pow. Gotta love Deno, that's kind of sick. Alright. And good. CLS npm init because my next step was npm init. Package name is Neo. Version, I'm going to start with a 1.0. And the description is going to be this. Entry point will be, my entry point will actually be, I wrote it down here. I plan on my entry point being lib. slash mod.js as a matter of fact. So it's going to be lib slash mod.js test command. My test command I said was going to be, oh, did I not put a test command? Oh, my test command, I'm not going to put one. My Git repository is going to be that. Keywords, I guess I can put some keywords. My other keywords that I already made, I could use those. So that should be like these ones, I guess. But I'm not going to use npm. I'm also going to have some other keywords maybe. Like there's that one, and I'll do TS for TypeScript because I'm going to be using TypeScript. Okay. Author, I already wrote down my note for that, for the author part in my notes. Or no, my plan. The author is going to be me, and I already wrote down all of the stuff because I keep forgetting the format. Oop, license is actually MIT, and that's all good, and CLS. So let's go check out the package.json. I'm not going to be using anything, I guess. Okay, my home. So let's go. I'll split screen these because I want to see my notes that I made. So my description. Actually, I like this description. I already made one. Interpreter for Neo, a scripting language for web automation. I actually like that one better. Dang it. I forgot that I wrote a description already. I did all this thought and I didn't even think about. Okay. I'm going to rename the package to EthanThatOneKid / Neo because I want it to be my package. Blah blah blah. Description homepage is going to be neolang.dev. That's going to be my homepage because I already have a working website for Neolang. Author, my main, correct. My types now, because I'm going to have some types, I assume. I assume Deno will export my types here as well. Lib mod.d.ts. That's cool. And now I'm going to declare my scripts. So I'm going to have my dev script. My dev script is going to just, since it's not even a program, it's going to be a library. So since it's a library, all I can really do is run tests. So I'm going to do dnon test to run my tests in dev mode. And I'm going to have some documentation generation because Deno comes with documentation generation automatically, and I believe this will work because mod.ts is going to be my entry file. So there's that. When I build, I'm going to want to Deno bundle mod.ts at, and I want it to go to lib/mod.ts. See how this is all coming together? Publish, and when I publish to npm, I'm going to want to do npm run build so I can execute this build command, and then after that npm publish access public so that it's a public package, and then after that I'm going to want to make a format one. Format is going to be Deno fmt. I can pretty much execute that on my own because if I do npm run format, that's way bigger than Deno fmt, so whatever. Could even run denon test. Okay, so I've got my dev, doc, build, publish, format. Okay, that's good. Now I think my package.json is good. I like the way it looks so far. Yeah, my package.json looks good. I don't need to put anything. I'm gonna put my notes up now. So there's my notes. I'll look at those later. Yeah, the first thing I'm gonna want to do is create my Lexer. Okay. So let's get this start. Or first, I'm going to commit my package.json. Commit. Go for it. Now I can add a new file called source/mod.ts. Wait, should I, instead of exposing mod.ts out in the open like that, should I put it in source actually? My bad. Yeah, I'll put it in source actually, which means I need to rename everything first. So I'm gonna delete that part first. I'm gonna edit this stuff. It's gonna actually be source/mod.ts. Source/mod.ts. Everywhere I said mod.ts, I should put source. That was actually pretty much it. When I make my docs, I want to start it here. When I make my build, I want to start it here. Alright, looks good. Looks good. Looks good. Alright. So save that. I'm gonna update it, and now I'm gonna add source and then mod.ts. So we're good. Okay. We got my module.ts. So I'm going to pretty much, I'm just going to like export the interpreter, or I'm going to export this as Neo. So it's going to be like, the thing that I'm exporting from here is going to be the actual Neo module. So where it's the interpreter part, where it runs all the commands. So in my get ignore, I'm going to want to, I don't really know about any of this. I'm gonna wanna, actually I'll edit this later. I'll edit the get ignore later. I just want to, I don't even know where to start. This is a big project. But all I have is the structure of an interpreter. So first thing we're going to want to do is make a Lexer. And the Lexer creates a list of tokens while ignoring comments. So I guess we should just make a new file. Lexer/mod. Oh my goodness, I can't type. Mod.ts. Lexer/mod.ts. So right now this is going to be the Lexer module. So I'm going to have a export default class Lexer, and in my Lexer I'm going to probably have a lot of private variables. So this class will keep track of all the keywords in the instance. It will provide the next tokens iteratively, and it will store grammar rules to simplify statements. So I'm going to just say, in my Lexer, I'm going to want to make a constructor, I guess. I don't even know what I want it to take yet. I'll probably let it take some grammar rules, which I will show in a second. So grammar should be of type grammar. So maybe that's what I should be doing, and privately exposing grammar as a grammar thingy, and then going to this dot grammar equals grammar. And what grammar is going to be it should be like an interface, I believe. This is what I'm gonna be trying to do. Interface, grammar. What is inside grammar? So what's inside grammar is going to be like a token. So a token, which is a string, right? And then inside that token, I'm going to want to put like arrays of arrays of arrays of arrays, like recursive arrays. Because in my grammar, I'm going to treat arrays like OR operators. So if I have one or more options, I'm going to put them in an array. Otherwise, it's going to be a string. So it's just going to be recursive. So how do I implement recursive arrays? Recursive strings and arrays in recursive arrays in TypeScript. How do I make a recursive type array? This guy wants to have that, but I want to define a type of array like nested array equals atom, where each AI is an atom or a nested array. Ah, yes, that's exactly what I want to do. Type aliases can't reference themselves, so this naive approach will fail. Interfaces can, however, reference themselves. Ah. And we can define an extra union at the top level to handle the root case. We can define an extra union at the top level. So atom. So interface nested array extends array, which can be an array of another nested array or an atom. So an atom or array. That I don't need because it's always going to be a nested array. So my nested array is going to. I see what's going on here. So it's going to be a grammar rule. So a grammar, yeah, I guess I can make an interface grammar rule. And this is one reason why I wanted to make this in TypeScript, because I knew that I would be able to get really strong types from this. So type atom, I'm going to be using like a type like raw token, I guess I should say, is equal to a string, I suppose. I don't know. I'll change that later because there's going to be different types of tokens like that I will expose. It'll be programmatically editable, like I can change them. So one grammar rule extends an array of another grammar rule or a raw token, and inside the grammar rule, oh, okay, I don't really need, right? Does that work? A grammar rule is just like this, because there's no grammar rule. Like, that's pretty much all I need. So my raw token is actually going to be a token. Like, these should be the same actually, but watch, it won't let me. It will not let me, and I'll tell you why. It says an index signature parameter type cannot be a type alias. Consider writing string instead, because it doesn't let me, even though it's an alias. If the alias means what it means, it still doesn't let me for an interface like that. So this should be good. Basically what this is saying is it's an array, which can be another grammar rule. Yeah, that's fine, I guess. I don't know. Type grammar rule equals array grammar rule, or what? Right? Should I just do this? Wait, does this work too? Type grammar rule equals grammar rule or a token as an array. That kind of works. That looks like it's fine. Okay. So those are my types so far. The reason why I want to have a map right here for my grammar type is because I keep spelling it wrong with an E because that's how it feels. Okay. We should be good. Grammar is declared, but its value is never read. Correct. I haven't read it yet. So my grammar, maybe I should export it as another type, as another file maybe, from another file. I'll do that another time, but for now I'll just say const main, or const, I'll just have a global grammar which is of the grammar type, and I'm going to say, for example, let's say a digit is I keep spelling it with an E. Okay, digit is, so first I need to tokenize everything. So once I tokenize it all, that's how I will know what everything is. I'm going to change everything into an array of, or a stack of tokens. So one of my tokens is going to be a digit. So in my grammar, what should I call it? Like a number literal, an integer literal, integer literal is just a digit. And so let's see why this doesn't work. Element destructuring pattern expected. Why? Oh, I didn't put an equal sign. My bad. Everything looks like it works so far. So a grammar rule is going to be an array of more grammar rules or raw tokens. This was a raw token, a digit. So what I kind of want to happen in the future is I want to have, like, watch, binary operator. This is kind of what I want to get accomplished today. So a binary operator, I want it to be like a number. I guess I'll just call it number from now on. And then inside I want to have a choice of binary operators. And then finish it with another number or another binary operator maybe, which would be which I could do like number or another binary operator. And inside of here I would be putting like plus, minus, divide. Maybe I should line break these because it's getting out of hand, but here we go. Because what I'm basically trying to say is that a binary operator will be like, I want it to be these types of tokens. So I expect a binary operator to start with a number followed by a plus, minus, divide, multiply, what else? Modulus. I'll do a modulus operator. Or modulo, I don't know. Is it modulo or modulus? Modulus. Modulo. I could just do anything else. What else do I have? Like an and statement. I could do greater than, less than, and, or, and then after that I can have just another number which will terminate my binary operator and allow myself to continue, or it can be another binary operator which will recurse the statement. So like, for example, let's say I have my expression has like 3 plus 3. So first my program would recognize, oh, 3 is a number, and then followed by a plus sign, followed by another number. So it will terminate right there. And I will have a terminal expression. However, if I decide to put another minus sign and then put like a 5, so I expect a number, I get 3, expect a plus sign, get my plus sign, and then I do get another number, but I also am getting another binary operator. I'm getting this. So when I get this, then, so now this is my number, or this is my next number, and then, or actually, so this is my binary operator. My binary operator starts with number plus minus number. So I'm going to have 3 plus 3 minus 5. 3 minus 5 will terminate first, and then I will get plus 3. So the way that this grammar works, I would probably get like -2 plus 3, which is -2 plus 3, which is 1. So that would work. I think in my language, what I'm going to want to do is I'm not going to really care about making what I want it to do design-wise is I want everything to go from left to right, left to right. No, like for example, if I do times 2 plus 3, I don't want it to do this first. I want it to just do step by step to avoid confusion. Because if it's step by step, then the programmer will know everything. So I believe my 30-minute time has begun. Our 30-minute break has begun, which means that I will take a break, I guess. I don't even know what to do. I'm confused. But I should just relax, take a chill pill. We could pause my coding because I'm not going to code right now. Coding is going to be a pause. So what was my pause? I closed it. It was in let me open it again. Hold on a second. It was cut. So pause, I'm gonna cut it. There we go. Paused it. It's all good. I'll close this. Okay. So, what am I drinking? This will be the first one. So in front of me I have a cactus cooler. I don't know about you guys, but I live in California. I don't know if they sell cactus cooler wherever you live, but cactus cooler is basically the soda, and it says orange pineapple soda, naturally and artificially flavored. Orange pineapple blast, and it has like a desert vibe to it. Desert aesthetic to the can. Really sweet, but it's refreshing sometimes. And I also have a glass of ice water. Because the reason why, let's just sit and think about this for a little bit. The reason why I want to have a grammar like property is because this class will keep track of all the keywords in the instance. So like when I make a new interpreter instance, I feel like this object should keep track of everything, because what's going to happen is it's going to convert. So I guess the first thing I'm going to want to do, I don't know if, okay, here's what my problem is. My problem is that I confused my lexer with my parser. My parser should be the one dealing with this grammar stuff, okay? My lexer should be working on converting all of the raw text into tokens. That's what I'm gonna work on right now. So my lexer will just return a stream of tokens, pretty much. So this grammar stuff, I'll just go create a new file. I'll say parser / mod.ts. And in here, I'm going to just put this grammar crap. I'm going to make some comments to remind myself of this grammar stuff. So let's go back to the lexer. Should be good. I guess I don't want this grammar part right now. In my lexer, I'm gonna want to put some raw, but I don't want to make a new lexer every time. So my constructor should basically just be some configuration config, which is gonna just be like some lexer config, and the lexer config is just going to be an interface that I will describe later, I guess. Interface lexer config, and it'll just be like anything, I guess. Whatever, I don't need it. The configuration should be private, so a private config is just going to be my lexer config, and then I'll just keep it in here as this dot config equals config as a copy, so I'll just copy it there. Okay, so that's my constructor. Right now I need to make another object called export. I'm going to export a class called token, and in my token I'm going to want to give it a type. So a type of all the different token types that there are. I'm going to have a lot of token types. This is going to be really crazy. Okay. So I'm going to have a private type. of token type. So it's going to be, since this is TypeScript, I knew I would have problems with this exact problem where I'm going, because my token class is going to have a property called type. And because this is TypeScript, it's just like, I don't know. Hopefully it's not that complicated, but for right now, I'm just going to say all the token types are strings. But later I will specify, because, for example, I'm going to want to say like my plus sign, my minus sign, all of those. I want to put every single thing in there. But for now, I'll just put string. So type, token type, and value is going to be, it's going to be tough. It's going to be like, in a token, what can my token have? Sometimes it'll be null. Like, just the fact that it is what it is enough. Like, for example, if it's a parenthesis, just the fact that it's a parenthesis is enough. But if it's a number, like if it's 86, it needs to have a value. Same thing with a string literal. String literal needs to have, maybe I should do it like this. Maybe I should have the token type. So the token type should be up here maybe. So I have my token type. So for example, I would be like, if my, well, what would that do? If I make a new token with a type like that, what's going to happen? I don't know. Like if I do it like this and I have my value, because I have to program it differently depending on what type of token it is. Like for example, if it is a number token, a number literal, I'm going to have to say the value of number. If it is a string literal, I'm going to need to have a string as the value type. So how would I program that for the value? Oh man. So I would, it would be like if this token type is a string literal, then this would be a string. If it's a number literal, it would be a number. If it's anything else, it would be null. So how would I go about writing that? Oh, also I should probably undo my split. My split is going to be, there we go. Continuing. Okay. Continuing on. I was just talking to myself. Okay. So token. How would I go about this? Because I'm gonna, let's think about this. Let's say conditional types in TypeScript, like if, you know, like how I was talking. I guess I searched this already. Using type predicates. So to define a type guard, we simply need to define. So if it is a fish, interesting. If swim in, the n versus a narrowing expression for type of. Interesting. And then I say, so the class can implement that. Okay. Wow, this is really complicated stuff, man. So the pattern is going to get random pattern. Oh man. Instance of, oh man. I just want to get it like, I guess I'd have to make a whole new, like, class, but I just want to keep it as a token, right? My type is just the token type. Uh-huh. Oh. Okay. 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 That's okay. Okay, so I'm gonna do that. But here's the problem. I don't want to just put any, you know? That's bad. I cannot do that. So constructor, when I make a new type, I don't really want to do that. I want to say, oh man. Maybe I should just refactor that later, but I feel like it would be a good thing to do it like that. I don't like this. I feel like I should, like when I create a new token, I feel like I want to say something like const token is equal to new token of, and then it's going to be like number, right? And then raw string. You know, like, doesn't that sound like the right thing to do? Expected zero argument. So like, because then I can take the raw string part of it and turn it into what I want it to be. So maybe I should do that. So maybe it should be, so how do I get, okay, that should be okay. So the type itself should be a token type. Ooh, this is complicated because I want the type token type to be, okay, I can do this. I want the type token type to be, man, what do I want it to be? I don't really need this if I'm gonna be doing T like that. Value is going to be, man, I don't want it to be any though. That's the problem. I don't want my value to be any. Oh, that's my problem. Okay, so my raw value, I definitely want my raw value to be a string. My value, my real value, that depends. It depends. And that's why I don't want to put, okay, I'll just, here we go. Null or string or number, okay? That's what it's gonna be. I'm going to put, for the raw value is going to be a string, for sure. For sure, string. So this dot raw value is equal to the raw value. And then here's where it gets interesting. If if my, okay, this is what I want to do. I want to check against something. So I'm going to get if number instance of t, and t is going to be the Oof, it's going to be the token type, but I want to keep. Oh my goodness. What types of token are there? There's going to be token, so like parentheses, number literal, I mean, dang it. Number, so it's going to be, so right now in this test, I'm just going to have number literal. I'm going to have plus. I'm going to have, that's all I'm gonna really have right now, okay? I'm gonna have string literal, I guess, why not? String literal. Okay. Like these are the, how else would I define what's going on? Like with this token type thing. Oops, my mistake. How would I go about this? Oh, it's saying that it has to be a variable, not a literal. That's so lame. Let's say what if type of T or type of ah man, what am I doing, dude? This is tough. I want to have a token with a token type, right? I want it to be a token type. But it has to be a type. I don't know what to say. T is declared, so type parameter. It's a type parameter. It needs, like, my token is that type of token. But I want it to operate differently if it is a different type of token. Oh, it's so complicated. Because all I want to do is pass it. Like, I might as well just be passing it the token type and then a raw. Okay, so here's what I'm gonna do. I'm going to get the raw value and I'm just going to say what the type is. The type has to be a token type, right? And the raw value there. So then type is going to be token type, perfect, whatever. This dot type equals type, and then here I'm going to say if this, or if this dot type is equal to number literal, or I can do it like this actually. This dot value is equal to type is equal to number literal. Then it's going to be number of the raw value. And then if it's if the type is equal to string literal, then I'm gonna want it to be like string of itself, which is just going to be the raw value, and then I'm going, otherwise null. Otherwise I want it to be null. I can keep that on this line. Hopefully that turn array operator isn't that bad. I could actually, let's just do this, Deno FMT. That's how they want it. It's cool for now. Okay. So when I create a new token, that's what happens. Okay. For some reason I really felt like doing this, but I guess there's no real point. That's fine the way it is. Okay, so in my lecture I'm going to take a config and I'm going to take a read. So I'm going to take some text, and the text is going to be a string every time. And when I read anything into it, it's going to be, so my stream is just going to be an array of tokens. So it's going to just be token with an array like that. And then I'm going to say this dot stream, or more like stack, my stack, because it's an array. So my stack is just going to be like that. So when I read text, the first thing that I want to do is transition everything into some, what am I trying to say? I have some note about what I want to do somewhere, because I need to like use regex for this type of thing. I need to ignore comments, right? Like let's just say my, man, I just need to, and I guess in the Lexer is where I need to be like showing my keep track of, like, this should not be where it stores the grammar rules, and right here it should be storing the line number as well. So here I'm going to do line number, or line, which is just going to be a number. Okay, which comes after the raw value, so line number, line number. But it should also come at the column number. That's annoying. This dot line is equal to 0. No, line. Right, that's good enough. Token has a line number. For now, I'll just do the line number, and I'm not gonna do the column number yet. Ooh, it's getting hot in here. I'm a little sweaty. It's getting really hot in here, but I don't want to turn on a fan, because if I turn on a fan, then my then my audio turns to crap. Okay. Let's see here. So if my blah 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 blah, I need to get onto the text. When I have text. So I have my stack, and it's gonna be like parentheses and stuff, I guess, because I want to test my numbers. I don't think I need this Lexer config yet, but I'm just gonna keep it there for now. For token type, I guess I'll put that there. For this, I'll put it under where Lexer is. I'm going to probably later on when I refactor all of this, because this is going to go under a lot of refactoring. When I refactor all of this, I'm going to put all these type declarations in a separate type declaration file. So I'm going to have to research how to do that eventually. Okay, so my stack of tokens. So every time, I'm just gonna. There was something I was reading. There was an article I was reading earlier that I really liked. Ooh, my repo is not found anymore. Right. I should change those in the README. Anyways, because I need to fix all of this stuff. It's like broken right now. It's not gonna work. Because it's under development, which I should probably post. I should probably post that it's under the extreme makeover right now. Maybe I should explain that. It's in an extreme makeover mode soon. I'll do that in the next break, I guess. I'm just trying to think about where this one thing was. If I saved the link anywhere. Yeah, I saved the link. I believe this is it. This guy explained how to do all this stuff pretty easily. But he's using like a library, I think, but the ideas are still there. This is kind of what I want to get done with today. Like a token with an integer, and then the value of it. I don't really understand how he did the expression. Right, so when I go to my grammar, well, first I need to get next token, eat expression. Interpreter takes the text. How did he do that? Interpreter takes the text, like just straight text. Self-dot position is an index into the text. Current token equals nothing. So interpreter. And then all he did was he got his raw input, and then he said interpreter.expression. So expression is an integer plus an integer in this case. And what he does is he gets the next token. So what is get next token? Get next token is a lexical analyzer, also known as scanner or tokenizer. So this is going to be his tokenizer. So my lex, what is he calling this? He's calling this his interpreter, he's calling that his token. Yeah, I guess my lexer is technically my tokenizer. I can just say like AKA tokenizer. Tokenizer or tokenizer, I don't know. So he gets his next token. How does he get the next token? Get next token. This method is responsible for breaking a sentence apart into tokens, one token at a time. So the text equals the text, okay, is self.pause index past the end. So if so, that would be an end of token, because there is no more input left to convert into tokens. Okay. Get a character at the position self.pause and decide, or self.position. So get a character at that position and decide what token to create based on the single character. So if the token is a digit, then it has to be an integer literal. Increment the self.position index to a point to the next character after the digit and return the integer token. So what he's doing is he says if the current character at the current position is a digit, then return token current blah 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 self dot position plus equals 1, and then if it's a plus sign, interesting, and then saying it's an integer. So eat. Compare the current token type with the past token type, and if they match, so compare the current token type with the past token type, and if they match, then eat the current token and assign the next token to the self current, otherwise raise an exception. So if it is so like let's say my current token is, oh my goodness, basically like, that's annoying. So set current token to, so the current token is going to be me getting, so like at the beginning, in this case it was a 3, right? Because he uses 3 plus 4. So let's just test this using 3 plus 4. So get current token equals self.get token. So it's going to be a 3. Self.current token is a token that represents the number 3. So we expect the current token to be a single digit integer. So left is going to be the current token, and we're going to eat it. So self.eat an integer, just the type. Eat, all the eat method takes is the type. So compare, in this example, compare the current token type with the past token type, and if they match, then eat the current token and assign the next token to the self.current token, otherwise raise an exception. Oh boy. Okay, I'm gonna be honest here. I'm gonna say something, and it's not gonna be nice. It's not gonna be nice. It won't. But here's what I'm gonna say. What I'm gonna say is I can totally do this. I can totally do this Neo interpreter thing in like a normal situation, but the code casting part of it is really distracting because I keep thinking to myself that I need to be talking. Like, as you can see, I barely, like, let's look at my code. I feel like if I didn't do this Codecast, because we're obviously already a whole hour into our Codecast episode, and I only have like 30 lines of code. And I honestly don't even know what I'm doing right now because I'm so distracted with the Codecast. Because this is something I've never done before and it's a very complicated topic. So I'm like learning it at the same time and I'm a little distracted. But if I were in a normal setting, I could. So I feel like maybe I should pause or end the Codecast episode soon, get a lot of work done on the repository, and then in a later episode I can show myself refactoring everything and stuff. Wouldn't that be more fun? I feel like that would be more fun to get most of it all figured out, get most of it all up and running, like at least to this point right here. After the parser, like, because the parser is where I create my my abstract syntax tree, AST, my abstract syntax tree, which is going to be the most interesting part of it. So and the most complicated. So I feel like after I create the way I get my abstract syntax tree, then I should start recording myself either continuing on with the compiler part of it or refactoring or both or whatever. I'll have a better plan that way. So right now I'll just say that I ended my first Codecast, ended the Codecast early because I'm a little tired of it at the moment. Oh, it's really hot in here too, because if I'm doing a Codecast, I can't have my fan on, because if I have my fan on, then my audio gets messed up. So I'm gonna end this. I stopped coding, so I should probably pause this. It was, oh, well, check that out. An hour. Cool. An hour just passed. Okay. Yeah, I'll just go ahead and end this Codecast early because I'm kind of not underprepared. Yeah, I guess underprepared because I needed to like be more aware of what I was doing. I thought it would be chill to like learn how to do it on record. I thought it would be interesting, but I highly doubt it's interesting, first of all. Second of all, I think it would be more interesting to watch myself refactor code that I've already created and spent a good amount of time thinking about and perfecting and stuff. I feel like that would be more interesting once I'm more well prepared and everything's more thought through. And also I will be showing how to do all the other things I talked about earlier, like with the like using npm and stuff and getting everything working like that. I thought that would be cool. I'll show you guys. I'll also talk about some ideas that I had for the language. At this moment, I'll say that some future ideas include events that trigger upon visiting a specific site, because this language is supposed to be an automation language. Like, it will automate things on a web page, pretty much. So having events that get triggered upon visiting a specific site or something happening, I thought would be interesting. Or events that trigger for every variable. So for example, every variable automatically would have access to an onChange event. So every time the variable gets changed, I can fire an event. I thought that would be cool. I don't, because Svelte kind of does that. Svelte is a front-end framework in JavaScript that kind of does that in a way. I think it's really cool, but it uses an object called a store, but this one would just be embedded into the language, which I thought would be cool. So end goal is a programmatic interface that takes in raw code one piece at a time and executes statements as they are completed. So yeah, that's I kind of wanted to implement that. Like, for example, if I throw up a command prompt, I'll show you my command prompt. Why is it my properties? Here we go. Font needs to be way bigger. Okay. Like, for example, let's say node, watch this. So let a equal 0. And then let's say let b equals 2. B is 2. Like, it's letting me do my program one at a time. Like, for example, function x, or function hello, or function say hello, I mean, would have, and then look, it doesn't complete. Like, this right here is what I want to do. This is not a complete statement. Function hello, open parenthesis, close parenthesis, open curly brace. It knows that this is not the end of my statement, and so it's allowing me to continue adding things until my statement is ended. And I feel like that's a really cool feature that I want to have implemented in the Neo interpreter, which is why I didn't want to just put the raw text here in my lexer. I wanted to have a read method so that I could add things to the stack. So it's not a one pass, it would be programmatically passed every time, you know. So it would be, so let's just say console.log hello, and it still knows that it's not done because I didn't put my last curly brace. Now it's done. Now I can say hello, oh, oops, say hello. Dude, this is a really good, look at that. Say it automatically guesses that I want to put say hello, and this is all in the console. Node is a really good language compiler thingy, I guess. But if I press tab, it auto completes, and then, oof, I don't think I can do that. But this interface right here is really cool. Oh, I should do clear maybe? Clear is not defined. Maybe I should do process.exit. Boop, it's over, CLS. Okay. That's pretty cool. I'll just go through my news right now since I am ending it early. What am I drinking? I already did that. Multicade development. So Multicade is a personal project that I'm working on, another personal project, which is like I don't want to give too many details because I don't want to spoil too much of it, but what I want it to be is to be like a virtual arcade, to get the same vibe that you would get from going to an old arcade back when people used, because I was not alive at this point in time, and I've always been very intrigued by the vibe. That I've never experienced this truly, but every time I watch it in like a nostalgic setting, like for example in a movie or something, like in Stranger Things even, all the kids go to the arcade and they all hang out, and the arcade looks so cool, and there's all these games, and it's busy, like there's a lot of people there, and there's people's names on the leaderboards, and people that go into those arcades know like who's the best player based on their names, and it's just like a small tight-knit sort of vibe, but it's also like futuristic because it's video games, but it's also nostalgic because the video games look really old because they're older. So I don't know, that's pretty much my inspiration for Multicade. It's going to be an online arcade where you can walk around as a character, like Club Penguin, kind of like you walk around as a character, but it's an arcade, and all the arcade games in there are made by people who play Multicade. So I'm going to have like a whole developer scene in there, and people who want to develop games or to have machines placed in the Multicade, they can make their own JavaScript games and then link their GitHub account, they could link their repository that has their JavaScript game in it from their GitHub account, and then be able to upload it, or not upload it, but link it to Multicade and have other people play their game in like a service worker sense or whatever. Like I need to do a lot of research to understand how all of this works. But my main goal or vision, my vision is that people who want to make games for Multicade can have a GitHub repository that has their JavaScript game or whatever game they want, and the freedom of it. I want the developers to have a lot of freedom. I don't want them to be restricted to like a library or anything. I want them to have minimal restrictions and lowest barrier to entry possible. I want everybody to be able to easily do the things they want to do the way they want to do them. So there's not going to be any JavaScript library, like anything that you can post on a web page, I want to be able to be playable on Multicade. That would count as a Multicade game. They could even have their own third-party database or server as part of their game, and it would be their third party. and there would be and for multicade there would be an in-game like shop or an in-game type of an in-game economy where every day everybody gets a certain amount of coins to be able to play their games, their favorite games in the arcade. So like for example, they would start their day off with 100 of their daily coins, and then they have two types of coins, like a daily coin and a multi-coin. For example, I guess I could call it a multi-coin because it's called multicade. But anyways, like a multi-coin would be a coin that you can use every day. So if your daily coins run out, you can still keep playing by overflowing into your multi-coins. Which I don't know if that's going to be a good business model or what, but I haven't seen anything like that. So maybe it's cool, maybe it's not cool. But I feel like having an in-game economy of multi-coins would be cool, and a really cool incentive for people who are developers to get, or oh yeah, also I thought this would be cool for players who have high scores on a really popular game. So the more amount of players a game has, the higher a prize for, like, so players who get a high score on a game, maybe like I give them a week, like it would be a season. So every season would be like a week or a day, depending on what the developer the developer of that game says. So let's say I make a clone of asteroids for fun, or whatever, yeah, like a clone of asteroids. And if you get a high score on that, and there's like 70,000 players on that game, and you get the high score, you would get a substantial jackpot of multi coins. Like that would be your reward, and then you could play more games all the time. But if that game has only like 2 players in it, then you would get a small amount of multi coins as a reward, but it would be honorable. Like it would still be cool. So I thought that was a cool business model. Hopefully nobody steals that idea before I finish implementing all of it. I should probably shut up and not say anything else. I don't know if my ideas have any value or not, but that's my plan. So far I have a front end going. My front end is SAP or Svelte. I'm using Svelte as my front end. And I so far have a player that walks around. That's all I have. And also, that's not actually all I have. I created a component in Svelte that is pretty interesting actually. I think I should talk about it another time. But in short, what it does is it allows for 3 different modes of input to work the same way. So for example, if I want to walk around in my game with my joystick, I can use a custom made joystick component HTML element that I created, where you use your mouse pointer or your touch pointer with your finger. You can use your finger, you could use a mouse pointer, you could use an Apple Pen to touch this joystick on a screen to make the player walk, or you could use directional keys on a keyboard to make the player walk, or you can use a gamepad like an Xbox controller or an SNES controller that you plug in through USB, and they would all work the same way. You could use a D-pad on the gaming controller, or you could use the joystick on the Xbox controller, and it will all work the same way. So all these different modes of that's one of the main visions I wanted to have, like for example how I said low barrier to entry, stuff like that. Some common ideals that I want to have with this product. So like just that type of stuff. I just want to have all different types of input available for accessibility purposes. Oh, and I also created like what would you call it? Oh, the button maps. So if I don't want to use WASD for directionals on my keyboard, I can replace them to other keys on my keyboard. If I want to use different buttons on my gamepad, like if I want to use different trigger buttons or different face buttons or whatever, different D-pad buttons, I can remap them. Like everything can be remapped the way you want, like the player wants them to be. So all the developer needs to do is the developer needs to say, needs to tell Multicade when they develop their game, when they configure their game. All they need to tell Multicade is, I'm going to, like for example, I'm going to use a primary button, a secondary button, and a joystick. Like for example, all their game needs is 2 buttons and a joystick. So what's going to happen is the player gets these 2 buttons and a joystick on their screen as the client when you play the game, and what's going to happen is they can map only the buttons they need to play the game, those 3 input methods, the joystick and the 2 buttons. All they need to do is map those if they want to. So that's just what Multicade is. Okay, moving on. I got a job for Code Ninjas. So right now I do have a physical job that I go to sometimes. A few days a week, like 5 days a week sometimes, depends on the schedule, because the schedule is highly variable. But Code Ninjas is basically like, I don't really know how to explain it. Like, I'm not Code 10, silly me. Code Ninjas. Code Ninjas, your kid will love learning to code. Oh, okay, so it's like a daycare service pretty much for kids, but it's like elementary school to middle school age kids, and it's basically like you get your kids, that is not me. But your kids, I do have that shirt though because I work there, but your kids get sent there, and it's like a karate class but for coding. And what I mean by that is like you start, like in a karate class you would start as a white belt, and you go on through all the belts to become a black belt, like in taekwondo, karate, whatever, I don't know. But it's kind of like that, but for coding. So we would start them off in their little white belt curriculum class, and then after they graduate their white belt, then they get to have this little wristband that's their white belt. It's really cool because it's actually kind of neat. Whoever thought of it's kind of cool for thinking of this, but instead of having a full-on belt, they have a wristband, and in the wristband, when they walk in to sign into the center, they hover their wristband over a device to sign in. So I think that's pretty cool, I guess. Kudos to them for that. But basically, I noticed this facility near my house, and I was like, ooh, because I like programming. That's going to be my career probably. So it's like coding, which is cool. And it's just tutoring little kids pretty much how to code, which isn't that bad. So that's all I gotta say on that note. So I guess I can end the Codecast now, now that I have all the news out of the way. Thank you for sticking with me if you watched till the end of the video. If you fell asleep watching the video, I hope you're having some sweet dreams. But yeah, I hope, I have no upload, schedule whatsoever. So, hopefully I'll see you guys later, whoever's watching this, in the next one. Alright, I'm gonna end it. Peace out, everybody.